I'm Anil Kumar. Here is a practice question to review vectors. The question here is, Yacht A's home port is at minus 10.4. Yacht B's home port is at 3 minus 13. They both leave their respective ports at the same instance. Yacht A's velocity is 2 minus 1 and Yacht B's velocity is minus 1, 3. Position in kilometers, time in hours, show that they do not collide. So that's the part which we are going to do. Well, in this question we have few other parts which I have removed from this video just to keep it short. Now this is a critical part. So we have two yachts which are moving and we want to say that they do not collide. Their paths may cross but they do not collide. That's what we want to prove. Okay. So first one, home port is this, and what is the direction? The velocity is that. Okay, so we can write the equation for the first one as xa ya could be written as initial position, which is minus 10, 4, plus time velocity 2 minus 1. As far as yacht B is concerned, it will be xb, yb. Initial position is 3 minus 13 plus some other parameter. Let's take s, which is also the time parameter t, but we're just taking it separate for the time being. You could take same because they start at the same time, so the same time. Okay. And the velocity is minus 1, 3. So why we have taken same time is the time, and they start at the same time. So as the time, if t is 1 for both. That's the whole idea. Okay. Now they say they both leave their respective ports at the same instant. Yacht A's velocity is given, B is given. Show that they do not collide. That's the question. That means we'll find the point of intersection of these two paths and then we will see if that time is same for both of them or not. That is how I think we can prove that they are at different positions, right? So the idea here is to find where the paths will meet, right? So we are saying that the two paths, okay. So let us try to understand the situation. So this boat is at minus 10.4. That one is at 3 minus 13. So let's kind of sketch it, right? And then we'll solve. Minus 10.4 and moving to minus 1. So minus, let's say this is 10. And 4, let's say this is 4 for us, minus 10.4, and moving like 2 minus 1, so going downwards, correct? So it's kind of let's say like this. Okay, so just a rough approximate. This is for A. As far as B is concerned, it is starting at 3 minus 13, so somewhere on this side, and minus 13 is kind of below, right? Okay, and it is moving left and up. So left and up. Let us say minus 1 and starting as 3 and minus 13. So let's say down there. And then it's moving left and up. So it kind of moves in this direction. So let me just draw a line roughly like this. And that is, let us say, the starting point for B. So they will cross over somewhere. They will cross over. But they may cross at different times. So this position is common. Okay. So that intersection we are going to figure out is a point where XAYA and XBYB is. So point of intersection is where we are saying XAYA. These positions are same. XB, YB, right? Now they could be same at different times. So I'm using now S here. Okay, so they could be same at different times. That is the whole idea, right? They may cross. Now if the time is same, they will collide. That's the whole idea. So I'm just taking separate S values. Okay. Now with this in mind, what I'm going to do is I'll write down my equation. So XA is equals to minus 10 plus 2t. And that should be equal to XB, which is 3 plus minus S. Okay, minus S. So this is one equation. The other one is for YA, which is 4 minus T. And YB is equal to minus 13 and 3S plus 3S. So we get two different equations. Okay. Now, from one, we can find a variable and then substitute in the other to find T, right? And then we'll find XA and YA. Okay. So, from this, we can say S is equal to what? So, bringing 3 to this side, we say S is equal to, bringing S to this side, we'll leave 3 here. So, we have minus 10 plus, okay, what I'll do here is bring S to this side. And so I got 3 plus 10 minus 2t, right? So that is equals to 13 minus 2t. Now if I substitute this here for S, I get 4 minus t equals to minus 13 plus 3 times 13 minus 2t. So that gives me 4 minus t equals to minus 13 plus 3 times 13 is 39 minus 6t. Bringing t's together, 6t on this side minus t equals to, bringing 4 to that side, minus 13 plus 39 minus 4, right? Okay, so this is 5t equals to, let's add this up now. So we have 39 minus 4 minus 13, which is equal to 22. So t is equal to 22 over 5. So 22 divided by 5 is, in decimals, 4.4. So we say t is 4.4, right? So if t is 4.4, S is equals to 13 minus 2 times 4.4, which is, let's use the calculator once again. 13 minus 2 times 4.4 equals to 21 over 5, or in decimals 4.2. 4.2. So S is 4.2 for us, correct? So what we see here is that they do reach at the same point, but their timings are different. Do you get an idea, right? So since their timings are different, they don't collide. Perfect. And we can find the position when they are at the same, the position which they cross, by substituting these values, correct? So for A, what is XA, YA? So we can say XA position is minus 10 plus 2 times 4.4, right? Which is, let's use calculator. So it is 2 times 4.4 minus 10 equals to decimals minus 1.2. And YA is 4 minus t. So 4 minus 4.4, which is minus 0.4. So that is XAYA, right? Now let us find the position for the other boat. Using S 4.2, we should get the same value, right? Okay, let's check. XB is, B is 3 minus S. That is 3 minus 4.2, right? Calculate this. And YB is minus 13 plus 3 times 4.2, correct? Calculate this. Let's calculate both of them. So we have 3 minus 4.2 equals to decimals minus 1.2. And for YB, we have 3 times 4.2 take away 13, which is in decimals minus 0.4. As you can see, they perfectly match, right? So they match. So the position is, well, not as per our diagram. So it is more on this side. Okay. So the position is they meet at minus 1.2. So point of intersection. So we can write down our answer. Position. So path cross at minus 1.2 minus 0.4, and they cross at different times. Since they cross at different times, they do not collide. That is the idea, right? So what are their times? Both A crosses at after 4.4 hours. So this takes 4.4 hours to cross. The other one takes 4.2 hours to cross. Okay, so there's a difference of 0.2 hours. That is to say 0.2 times 60, 12 minutes, right? So difference of 12 minutes. So they don't collide, correct? So that's how we can actually solve this question. Okay, so I'm Anil Kumar, and I hope all these methods and these videos are helping you to understand applications of vectors when applied to different topics. You can always share and subscribe to my videos. Feel free to write questions. Thank you and all the best.